Hi everybody, Mrs. Bowen here, and we're going to take a look at Learning Target 4.5. I can write equations from word problems and solve them. All of the word problems that we look at today are going to be in slope-intercept form, which we've worked with before. Slope-intercept form is y equals mx plus b. And let's break down the different parts of this form that we'll be able to identify in our various problems. So let's start with the b. The b is our y-intercept. We can make a note, the b is our y-intercept. And when working with the y-intercept in these story problems, the y-intercept might be something like a flat fee that we have to pay. It might be a startup fee or a startup value. It could also be just some initial starting position. Initial starting position. Your y-intercept is always where you start. And if you think back to graphing, that makes sense. We always had to start on our graph at our y-intercept or where the line crosses our y-axis. The other piece that we'll be identifying in these story problems or word problems is the m, or our slope. So again, m is our slope. And we said slope is rate of change. So we'll be looking for the rate of change in these problems. And sometimes, but not always, the problems will use the word per, P-E-R, to signify that that is our rate of change. So keep an eye open. If you see the word per, then this means it is our slope or our m in the problem. So these are just some key words or key features to look for in these word problems. Let's take a look at number one. Number one says, in order to join a dancing club, there is a $30 startup fee. And as I'm reading this, I see startup fee. And we said a startup value is always our b, or our y-intercept. So as I'm reading, I'm going to make a note there. This $30 startup fee has to be my b. And a $4 monthly fee. This means I'll pay $4 per month. Do you see how I could insert the word per here? So this means that this $4 monthly fee is going to be my m, or my slope. Write an equation in slope-intercept form that models this situation. So keep in mind, in slope-intercept form, y equals mx plus b. The y and the m are just part of my form, and I need to plug in my slope and my y-intercept, which I've already identified in the problem. So I'll have y equals, and in this case, y is representing the total cost to join this dancing club. And my rate of change, or my slope, is $4 per month. So I could say 4x. And then at the end for my y-intercept, I also have this startup fee. So on top of paying $4 per month, no matter what, to even go to this dancing club, I have to pay the $30 startup fee. So this would be an equation in slope-intercept form that models the situation. Let's take a look at number two. In order to join an online learning community, there is a $20 startup fee. So there's my B. And a $5 monthly fee. There's my slope. Write an equation in slope-intercept form that models the situation. So again, we're here talking about cost, the total cost of joining this online learning community. So y equals, and my monthly fee, I pay $5 per month, so I could write that as 5x, plus my $20 startup fee that I have to pay on top of the $5 per month. Let's look at a couple more. In number three, it says, in order to become a member of the Library All-Star Members Club, there is a $40 sign-up fee. So that would be our B, sign-up fee. This is an initial fee we have to pay, and a $2 monthly fee. So that's going to be our M, our slope. So to write an equation in slope-intercept form, we'll have y equals, again, y is representing our total cost in this problem. And we're going to pay $2 per month, so that's 2x, plus, no matter what, we have to pay the $40 startup fee. So plus 40. Number 4 is going to have us use this equation that we came up with in number 3. It says, use the equation you wrote in problem 3 to find the total cost of being an All-Star Library member for 19 months. So we need to look at what this equation represented. The y was representing our total cost. Our total cost is equal to $2 times the number of months, because it was $2 per month plus the $40 fee. So this 19 months is going to go in place of x because it's $2 times the number of months. And now we know there are 19 months that you'll be paying for. So I would have y equals $2 times the 19 months plus 40. There's the equation that I need to solve. Again, I'm trying to solve for y, my total cost. And when I do that, I get y equals 78. Because this is a word problem, we should always look at our answers in context. So I should write $78 because we are looking at total cost here. So it's going to cost me $78 to be an All-Star Library member for 19 months because I'm going to pay $2 times those 19 months plus that $40 initial sign-up fee. Let's look at number 5. The U.S. Bureau of the Census predicted that the population of Florida would be about 17.4 million in 2010. So it looks like we're starting at this, 17.4 million. So there's my B. And it's going to increase by about 0.22 million per year. So I see this keyword right here, per, right? This is signifying my M, my slope, my rate of change. Which of the following linear models predicts the population Y of Florida in millions in terms of X, the number of years since 2010? Notice this word problem is throwing in some years, right? 2010, 2015. And these are just some extra numbers that we have in the problem that we don't actually need to write our equation. We already identified what the population of Florida was starting at, and we identified how much it's going to increase per year. So we can take a look at these equations. We know that our B, or the number at the end, our plus B, is going to have to be plus 17.4 at the end. So that means I can eliminate A and D because I need to see plus 17.4. That's my starting value, right? That's where the population is starting at. And then it's increasing by 0.22. Notice that's the difference between choices B and C. In B, it's negative 0.22, so that would be decreasing. We need to increase by 0.22 million per year plus where we started. So C should be the correct answer for that one. At this time, I would like you to go ahead and look at numbers 6 and 7. So in number 6, you will write an equation in slope-intercept form. And then in number 7, you're going to use the equation to try to fill in this table. So at this time, go ahead, pause the video and see what you come up with for you try 6 and you try 7. Let's see how you did. In you try 6, I noticed that I had a $4 initial fee plus $1.50 per hour. So here was my equation in slope-intercept form. And then in number 7, I was using this equation to fill in the table. So notice the table represented the number of hours in terms of X and total cost in terms of Y. So what this table is saying is I want to know how much I'll pay if I rent the bike for 2 hours. So I'm using the same equation, y equals 150x plus 4, and it's $1.50 times the number of hours, but now we know we're going to rent the bike for 2 hours. So I plugged in 2, I did $1.50 times 2, which is 3, 3 plus 4 is 7. And then I continued doing this for the other places in my table. Now for X, I was plugging in 4, 6, and 8 for my number of hours in order to finish my table. If we jump to the back side here, number 8 says, in order to join a yoga club, there is a $100 annual fee and a $5 fee for each class you attend. So $100 annual fee, that's like my initial fee that I have to pay, my B, and $5 fee for each class I attend, or $5 per the number of classes. So this will be my rate of change, my M. So I will have y equals my rate of change. It's going to be $5 times the number of classes plus this initial fee that I have to pay to get started. All right, let's look at number 9. And number 9 is actually going to go with numbers 10, 11, 12, and 13. So these all go together. Number 9 says Cameron is designing a calendar as a fundraising project for math class. The cost of printing is $500. So that's my initial value plus $250 per calendar. So that's my rate of change. Write an equation in slope-intercept form that models the total cost. So here we're representing total cost of printing the calendars. So I'll have y equals, it's $250 per calendar. So I can write that as 250x plus my initial value of 500. In number 10, we're still talking about the calendars, but now let's talk about how much money we'll make. It says each calendar will sell for $5 each. So it's going to be $5 times the number of calendars. Write an equation to model the income. Here is our total income, y, for selling X calendars. So we'll have y equals, and notice in number 10, we don't have a starting value, right? Because you don't automatically right off the bat start by having already sold some calendars, right? You've got to work to sell these calendars. So you have no B. That's like saying plus or minus 0 at the end. And that's fine. We talked about how your equation doesn't have to have a B. You could just start, when you think of graphing, you could start at the origin. So we do have a rate of change. It's $5 each calendar, or $5 times the number of calendars. So we can represent that as 5x. So this equation represents our total income. Number 11 says, Cameron estimates that the math class will sell 200 calendars. What will the total cost be? So here we're looking at total cost. So we need to look at the equation we used for total cost, and that was up here in number 9. We had y equals 250x plus 500, and it was 250 times the number of calendars plus 500. But now we know we're selling 200 calendars. So instead of writing y equals 250 times x, I'm going to plug in 200 because I know I'm selling 200 calendars. So again, I'm using the equation from number 9 because that was our equation for total cost. And it's 250 times the number of calendars. And here we have 200 calendars plus 500. We can do that math real quick. When you do that, we end up getting $1,000 for our total cost to make the calendars. That's in order to print them. Now let's look at how much we'll make. So our total income. Cameron estimates that the math class will sell 200 calendars. What will the total income be? So I'm hoping you notice the difference between 11 and 12. In number 11, this is representing our total cost. It's $1,000 to print the calendars. Now let's see how much money we're going to make, because we know we have to pay $1,000 to print them. What will our total income be? So if we look at our income equation, total income was y equals 5x, because we're going to sell the calendars for $5 each. So instead of writing y equals 5x, I now know I'm selling 200 calendars. So I can do 5 times 200. When I do that, I get $1,000. So what's interesting is it's going to cost me $1,000 to print the calendars, but I'm only going to make $1,000 income, $1,000 total in my pocket. So if you look at number 13, it says, determine how effective the fundraising project will be. Will there be a profit or a loss? If so, how much? We could say we have no profit, no loss, right? You break even. You're going to pay $1,000 to print the calendars. You're only going to make $1,000. So this seems like this is not going to be an effective fundraising project, right? All right. Let's have you at this time do 2 more U-tries. So I'm going to have you look at numbers 14 and 15 and see what you come up with. Go ahead and pause the video. In you try 14, we have a taxi company that's charging us a flat fee of $3, so that's our B, and it's 75 cents per mile, so that's our M. Here's our equation in slope-intercept form. And then in number 15, we were using this equation, but now we know how far our distance is. We're going 18 miles. So here this equation is saying our total cost is equal to 75 cents times the 18 miles that we'll go, plus that $3 flat fee. And when we do this math, we end up getting $16.50. So that means that our taxi ride is going to cost us $16.50. Last problem, number 16, says an airplane 30,000 feet above the ground. So here's where we're starting, 30,000 feet above the ground. That's our B. And we're descending at a rate of 2,000 feet per minute. Descending at a rate, right there, the word rate gives away, rate of change, that's our M. Write an equation to model the situation, and then once we write the equation, then we have to find the altitude of the plane after 5 minutes. So this is a two-part problem. So first let's write an equation. So I'll have y equals, y is representing my total altitude, so my altitude equals, and my rate of change is, be careful, it's not going to be 2,000 feet per minute. We're descending at a rate. Descending means going down. So we're going down 2,000. So that should be negative 2,000 feet per minute. So we could say negative 2,000 x. And then we have to consider our starting value or our initial value. We started up 30,000. Adding some commas there. So we're descending at a rate of 2,000 feet per, or times the number of minutes, plus our starting value. We started up in the sky, up at 30,000. So we did the first step, we wrote an equation. Now the second step wants us to find the altitude. Remember, altitude, our total altitude is represented as y, after 5 minutes. So this equation was showing us that we descend 2,000 feet per minute. And now we know there are 5 minutes, so we need to plug 5 in for x. So we'll have y equals negative 2,000 times 5 plus our 30,000. And this will give us our total altitude. When we do that math, we end up getting 20,000. And this isn't going to be $20,000. Keep in mind, now we're not talking about cost. We're actually talking about the altitude here. So if you look in the problem, you can find the units. We're talking about feet. So 20,000 feet. And here we are above the ground. And this is where our plane will be.